Hello, my name is Emily Branson. I'm from Abilene Christian University, and my poster is on the Fermilab E1039 or SpinQuest spectrometer. In my poster, I cover the physics motivation behind SpinQuest and discuss each part of the spectrometer. SpinQuest is an experiment at Fermilab that will make measurements of Drell-Yan-produced dimuons for the purpose of extracting the Siver function, which may be used to investigate proton spin. The Siver function describes the transverse momentum of partons relative to their parent proton and is related to jet asymmetries. The asymmetries that SpinQuest will measure are of dimuons produced in Drell-Yan events. The Drell-Yan process is when a quark from the beam and an antiquark in the target annihilate to become a positive muon and a negative muon. To measure these dimuons, SpinQuest will use the E906 or SeaQuest spectrometer with some new additions. The first major addition is a new polarized target, which uses solid ammonia and solid deuterated ammonia. The target is polarized so that the spins of the target protons will be known. This is important because SpinQuest is considering a possible relationship between the asymmetries measured and the spins of the protons. The spectrometer itself has two magnets. The first is Fmag, which is solid iron and serves as a beam dump and focusing magnet. Next is Kmag, which is open air and used for measuring momenta of trapped particles. The spectrometer uses three kinds of detectors: hodoscopes, drift chambers, and proportional tubes. The hodoscopes are arrays of scintillator panels attached to PMT bases. Because these give fast signals, they serve as the trigger for the experiment. The drift chambers are sense wires strung through a gas mixture, which are not as fast as the hodoscopes, but give more precise location information. Lastly, the prop tubes are tubes with sense wires suspended in a gas mixture, and are the final step in identifying the dimuons. So these are the detectors for the SpinQuest experiment, but some new hodoscope arrays have been added for the purpose of measuring dark photons that may be produced in the experiment. These measurements are outside of the scope of SpinQuest, but could potentially be used to investigate dark matter. To conclude, SpinQuest will use the updated SeaQuest spectrometer to measure Drell-Yan produced dimuons in order to extract the Siver function. I would like to thank Fermilab, the SpinQuest collaboration, the U.S. Department of Energy, and ACU. Thank you.